Hello students. Under the course Database Management System, in Module 3, today we are going to learn about the mapping of EER model to relational model. EER means Enhanced or Extended Entity Relationship Model. For this, we have used refer the following textbooks: database system concepts, then second is fundamental of database systems, and third is database management systems. It is also called as the mapping of generalization and specialization. These are the enhanced entity relationship model concepts. So this mapping of generalization and specialization hierarchies to the relational schema. Now, what do you mean by specialization? You can see in this diagram that there is a superclass employee, and there are this employee superclass is classified into the three subclasses: secretary, technician, and engineer. So employee has the attributes employee name, social security number, birthday, address, job type, whereas the secretary, technician, and engineer have their specific attribute like typing speed, technician grade, and engineering type. So this is called as the specialization, superclass, subclass relationship, or we can say that employee is a superclass, inherited three sorry. So employee superclass is classified into three subclasses. So this is also called as the inheritance. When the attribute, all these are the common attributes: name, social security number, birth date, address, and job types are inherited in all the subclasses. Next concept is generalization. Generalization means when we have two subclasses, one is the car and, for example, another is the truck, and car has the specific attributes and truck has the another specific attributes. Some of the attributes you can see that vehicle ID, license plate number, then number of license plate number, then the price. All these three attributes are common in both the classes. So we can create or a super class that is called as the vehicle, where the vehicle has, we can add all the common attributes in the vehicle superclass. So when there is a bottom-up approach, we call it as a generalization, whereas when there is a top-down approach, then it is called as the specialization. But when you see both the diagrams, we cannot identify that whether it is a specialization or generalization. It is a superclass subclass relationship. So superclass has the attributes which are common to the subclasses, and subclasses have their own attributes which are specifically for that subclass. So for this specialization generalization, we in the previous video we have studied the mapping of entity relationship model to relational model. In this video, we are going to study the enhanced entity relationship model to relational model mapping. So here step 8 and step 9 we are going to study. Step 8 is specifically for the specialization generalization, and step 9 is for the mapping of union types. We also call it as a categories. Let's start with the step 8. That is for the mapping of specialization and generalization. So when there is a specialization superclass subclass relationship in any entity relationship model, then we can say that this is specialization, generalization. Then we can say that it is a enhanced entity relationship. So for this such a type of specialization generalization, there are 4 options in step 8. 8A, 8B, 8C, and 8D. 8A is saying that if there is a superclass and subclasses, okay, S1, S2, S3, and so on, Sn, then what we can do multiple relations, superclasses and subclasses. Then multiple relations for the subclasses only. Then option 8C is saying that only one relation for all the superclasses, subclasses with one type attribute. And next is the last is single relation with all these superclasses, subclasses, but with multiple type attributes. Let's understand each and every option in detail with suitable example. So option 8A is multiple relations, superclass, subclasses. Suppose I have this specialization where the employee is classified into secretary, technician, and engineer. When we apply the option 8A is saying that for each superclass and for each subclass, create a separate relational schema. So you can see in this example that we have created a, for employee, we have created a separate relational schema with all the attributes which are specified in this EER diagram. So SSN, social security number, first name, middle name, last name. You can see here first name, middle initial and last name. Then birth date of the employee and then address of the employee and the job type of the employee. So all the attributes which we can see in the ER diagram will be specified here in the relational schema. Next, for the secretary, we are creating a separate relation for the secretary. For technician, we are creating a separate relation. And for engineer, we are creating a separate relation. And all these attributes, typing speed, which has to be added for the secretary, technician grade, which we have added in the technician table, or relation, and engineering type we have added for the engineering relation schema. What about this SSN? SSN is a key attribute. We can see is the primary key or key attribute for the employee, which has to be added in all the subclasses as a referential integrity. So SSN here, SSN will refer the employee SSN. Here also, this SSN is nothing but this SSN employee. And here also SSN is nothing but the SSN of the employee. So in the explanation, we can see that create a relation L for C with attributes. So C is called as the superclass. So superclass, for superclass, we have to create a relation. Primary key of this relation is key attribute. Create relation Li for each and every subclasses. So for each and every subclasses, create number of relational schema. So L1, L2, L3, maybe, and so on, L4, L5, and so on. So for each subclass, we have to create a separate relational schema and add all the attributes of SI. SI means subclass. So we have to add the attribute of L1, attribute of L2, attribute of L3, and so on. But the primary key, what is the primary key? Primary key of Li is the K. K is nothing but the primary key of the superclass. So the same attribute you can add here as a primary key of each and every table. This option works for any specialization, whether it is a total or partial that we have studied in the previous video. Here we can see that if it is a total, whether it is a total or partial, okay, or whether it is a partial, or whether it is a disjoint, or whether it is a overlapping, we can go for option 8A. Next, so here this relationship is a partial participation. Why? Because here we have not added two lines. Here it is a single line. It means that employee can be secretary, technician, engineer, or can be any other. Okay, as a role, he can be apart from secretary, technician, and engineer. That's why it is partial participation of employee. Next, option 8B. Option 8B is saying that instead of creating all the entities for superclass and subclasses, what we have to do? we can create only for the subclasses instead of creating a relation schema for the superclass. Okay, let's take one example. So in the previous slide, we have studied the one specialization generalization example. In that, vehicle is a superclass and car and truck is the subclasses. So when vehicle can, here we can see that it is a total participation and this is D for disjoint. It means that vehicle can be a car or truck, cannot be both or cannot be anything apart from that. So each and every vehicle can be either car or can be either truck. So if such a kind of relationship is there in the superclass subclass, then we can go for only creation of two subclasses. One is car and another is the truck. Need not to create a vehicle as a separate and relational schema. So here for the car, add all the attributes: maximum speed, number of passengers, maximum speed and number of passengers, and all the other attributes we have to inherit in the car from the vehicle. So vehicle ID, price, and license plate, all these are inherited here in the subclass. Similarly, for the truck, for the truck, vehicle ID is the primary key because it is a primary key for the each and every vehicle. Then license plate number, price, license plate number, price, and vehicle ID from this. Number of axles will be from this and tonnage. So I am writing here tonnage, which is not written. So here, these are the attributes for the truck. So this option 8B saying that create relation Li for each and every subclass. So for L1, for L2, for L3, we can create so many subclasses, attributes, how to be added for each and every subclasses along with superclass, along with the union of superclass attributes. So whatever the superclass attributes are there, that we have to add it in each and every class. Okay. Next. This option only work for the specialization whose subclasses are total. So if there is a subclasses with total participation, then and then only we can go for option 8B. Now the next option is option 8C, where it is written that single relation with one type attribute. Single relation means, for example, this is a superclass subclass relationship. Then instead of creating three relations, or instead of creating only two relations, what we do, we'll create only one relation by adding all the attributes of the superclass, all the attributes of the subclasses, and one more additional attribute that we have to add, that is called as the type attribute. So here it is written that one type attribute, only one type attribute we have to add. So this is a very simple. The attribute T is called type attribute. It is also called as discriminating attribute. Why? Because we should come to know that this tuple or this record belongs to which class, whether the person is an engineer or whether the person is a technician. We consider now the same example. Employee is classified as a secretary, technician, or engineer. So in this case, if the employee is a secretary, then this job type will specify that whether the person is a secretary or not. So for example, if we say that for secretary, we give as a values 0, 1, 2, then 0, it means that if it is a int, if it is, we consider as an integer, then 0, if we say that 0, then all these will be all the tuples, all the record belong to the secretary. Okay. In that case, T grade, if the person is a secretary, if the employee is a secretary, then the person has a typing speed. So there will be some value here. But technician grade is the explicitly for the technician. So there will be a null value for this. There will be a null value for the secretary. Similarly, engineering type will be null because the person is a secretary. Similarly, if the job type is equal to 2, it means that the person is an engineer. He has an engineering type, but other attributes will be null. So this will be the disadvantage of this option 8C. So in the option 8C, instead of creating superclass and all the subclasses separate relational schema, we are creating only a one single relation schema for considering all the attributes of superclass subclass in the single relational schema by adding only a one attribute that is called as the type attribute. Okay, so here we are adding the only a one type attribute indicate the subclass to which each tuple belongs. So in which this tuple 1, this tuple 2, this tuple 3, or we can say that the records will be belong to the particular job type. Okay. Next, option 8D. Option 8D is saying that single relation with multiple type attribute. So in the previous option 8C, it is saying single relation, but with one type attribute. But here in this option 8D, we have to consider multiple type attribute. Generally, such a type of option 8D is applicable when the superclass subclass relationship is a overlapping instead of disjoint. Here we are saying overlapping means not disjoint. Means overlapping means part can be a manufacture part or purchase part or can be both. So some part of the company or organization are manufacture as well as purchase part, then we can say that overlapping. For example, if the student is a alumni as well as he is a teaching assistant in the university, then we can say that both. He belongs to both the classes. So that's why we have to consider the overlapping as one of the specialization. In such a cases, instead of we can go for option 8D. So what we do here, we add the Boolean type field M flag and P flag here because there are two subclasses. So here we are adding two Boolean attributes, P flag and M flag. Now see here, part number, description. These are the attributes from superclass. Then drawing number, batch number, manufacture date. All these are the attributes of manufacture part, and purchase part from that supplier name and list price. These are the two attributes from the purchase part. Now these two attributes M flag and P flag are the Boolean type. Why? Boolean means either 0 or either 1. Suppose if I add a particular record of a particular part number P1, okay, the description, and I am saying that this is only a manufacture part, therefore I am saying it is 1. Okay, so either it is a manufacture part, when I add all these attributes, then other attributes will be null. Okay, because it is not a purchase part, and the P flag will be 0 because it is not a purchase part. But if the particular part 2 is purchase as well as manufacture, then we can put here 1 1. Okay, then that time there will be all the attributes of both the subclasses. So in this way, we can consider this P flag and M flag. Suppose the part P3 is only purchase part, then M flag will be 0. Other attributes will be null here because this is not a manufacture part. Batch number will also be null. Sorry, description, the value will be there. Okay, part number and description. Other attributes for this manufacture part will be 0. P flag, it is a purchase part, and the values will be there for the supplier number and list price. So you can go for the option 8D when there is a overlapping specialization. Okay. Next. So here we have studied all the four options. Option 8A, 8B, 8C and 8D. So when there is a superclass subclass relationship with the disjoint, okay, with disjoint or with overlapping or with total participation or partial participation. Based on all the categories, we have to apply either option 8A, 8B, 8C and 8D. Okay, these are the steps which we can applicable for the specialization, generalization when we create the mapping, when we do the mapping from ER diagram to relational schema. Now, next is option 9. Now, option 9 is for the union type, mapping of union type, or we call it as a category. First, understand that what do you mean union. So in this diagram, we can see that there are three entities. One is person, second is bank, and third is the company. All three superclasses, all three entities have their own attribute. Person has social security number, name, address, license number, driver license number, etc. Whereas bank has a bank name which is unique and bank address. Company has company name and company address. These are the three different entities. Now, next is the owner. Owner is the entity. What is this owner? Owner of a particular vehicle can be a person, bank, or company. So here you can see that car and truck, these are the two subclasses. From that, we are creating a registered vehicle. So car can be a registered vehicle or truck can also be a registered vehicle. So this registered vehicle owned by the particular owner. That's why owner is one of the entity. Now this owner can be a person or a bank or a company. So in the union, or we call it as a category, union means when superclasses are of different kinds and they have their own different key attributes, then we can union all these in a single entity set and add a separate attribute that is called as the surrogate key. So in the example, we can see here that person has person, social security number is the primary key and all the other attributes. Bank has a bank name and other attributes. Company has a company name and other attributes. Now here we have created owner. Owner means owner is one of the entity which is a union of all these superclasses which are different. So this owner, in that we have added a new attribute which is called as the owner ID. It is also called as the surrogate key, which defines that who is the owner of the registered vehicle. So if the owner is a company, then owner ID will be the company ID. Here owner ID also is added, which refers the owner ID from the owner, because owner ID is the primary key in the owner entity. And these are all the foreign keys, which will refer the primary key of the owner ID of the owner. So for mapping a category whose defining superclass have different key, it is customary to specify a new key attribute called surrogate key when creating a relation to correspond to the category. So in this example below, we can create a relation owner to correspond to the owner category and include any attributes of the category in this relation. The primary key of the owner relation is the surrogate key, which is called as the owner ID. So we can see that here owner ID is the primary key of the. This is all about the step 8 and step 9 for conversion or mapping of relational schema from EER to relational model. So thank you, students. Thanks for watching this video. Please like, share and subscribe my YouTube channel. Thank you very much.